So, the review for last lecture is that Git is a distributed version control system. What does that mean? Basically, it means that there are a bunch of different places for your files to be saved, and then as you move along, they become more and more secure in a way. So, it really helps out in terms of being able to keep track of your files as well as being able to roll them back and keep all of the versioning together, as well as to work with other people. So you may remember last time we talked about a bunch of different commands, and so we're going to do a quick review of those. The first one that we talked about was moving our files from the working directory over here to the staging directory over here, and that is git add. So git add is going to basically tell Git, hey, here are the files that I want to put into the next commit. And as I mentioned committing, let's talk about committing. So committing is basically taking a picture of the file system where you're at. So this is going to be basically the idea that you say, okay, I have added these files. I want these to be in the next commit. And I've now committed them. And that basically says, okay, all of the files that you added are now in this snapshot that we took. And now, whenever we go back, we can always take a look at those files and it will look exactly as it did when we typed in git commit. And then finally, to take our version of the repository that's on our local computer and upload it to the server in GitHub, we run git push. And this will upload the code and any commits that we've made to the remote repository. So those are the ways to go up. And then to go back down, we had git pull, which is going to pull those files back down to your local repository if anything gets changed on the other side. So say, for example, going back to our example from last week, if Welby pushed something up to remote, then we can then see the difference in the local by pulling. So let's talk about git pull. Git pull is not perfect, unfortunately. We love to live in a perfect world, but it's just not. And to demonstrate this, we're going to talk about a shopping list that we have. And I'm going to turn my camera off so that you can see what that says. Okay, so in this example, we have two shopping lists. So on the left-hand side, we have the local repository. Let me get a pointer. So yeah, you have the local repository over here, and then you have the remote repository over here. So looking at these two, they're up to date, perfectly normal. If on the remote repository, going back to that example, if Welby decides to add laptop to the remote repository and I run git pull, laptop is now going to be on my local repository. Cool, we're all good. Now that change is synchronized across both spots. However, what happens if, let's say, I change marker to pen? I really like pens instead of markers for whatever reason. And Welby decides he instead wants a pencil and a laptop charger, right? Now there's two different versions of what's going on. And because Welby pushed his up to remote first, that's where he basically got the changes pushed up first. So we're going to be the ones who have to figure out what the best solution is. So when we try and pull now, what we're going to get is an issue. So going back to this, right? We have pen over here, but pencil over here. How do we resolve that? So the answer is merge conflicts. Now, some of you have probably heard these, heard of merge conflicts, and they seem very scary. You get head and you get like this random number, you get equal signs everywhere. It gets very weird very fast, right? Git was supposed to take care of this, be all nice and helpful for you, and all of a sudden you now have a bunch of different stuff. So in this case, what's going on is Git is saying, I see a change that I don't know how to interpret, right? So remember, on the remote, there was pencil, but on the local, there was pen. So what happens is Git says, okay, here's what's on your local version, and here's what was on the remote. And it tells you this so that then you can go in and decide which one is the better way to do things and which changes to keep, which to throw out, whatever. You'll also notice that the laptop charger goes right at the bottom there, and you don't have to worry about that at all because there were no changes to that line on our local repository. It's only the lines that you change that are the same. So first off, what we have to do is get rid of all of the markers there. So basically we have three markers. We have the head, which is telling us, hey, here's what you were looking at. Then we have this equal, which basically tells us here's where what you were looking at stops. And then we have the remote, as well as a bottom piece here telling us, hey, here's what was on the remote. And this is specifically the exact commit, the number for that commit in hexadecimal, to let you know exactly where in the repository that is. So what we're going to start off by doing is removing all of the nasty stuff from around it. And next up, we're going to say, I like pens. I think pens are good. Welby, if you think pencils are better, too bad. We're going with pens. And so now we've decided which change that we want to keep. We could have also decided to keep both. It really just depends on the application and what we're doing. In this case, we're just going to keep the pens though. And now we've finished all this. We save the file and commit it, and then we're going to push it back up. And now the remote is going to reflect that. So now everything is back up to date, and it's the changes that we wanted, and we didn't have to go through any crazy hassles. So let's now talk, so a merge conflict happens when there's a merge operation and conflicting changes in similar areas. So going back to this slide, right, when we pulled from the remote, what git pull does is it actually runs two commands, git fetch and then git merge. So git fetch says, hey, here are all of the changes that happened on remote. And then git merge says, okay, cool, now that I have them, let's apply them to my local repository. And so that's why that happens. So merge conflicts, you need to keep separate from pull because it can happen anywhere. So a merge conflict is only whenever there's a merge operation. And it's when there's two different things that got changed in the same area. So why was there a merge conflict on our shopping list, right? Well, as I said, we were doing a merge operation by doing git pull, and we had two different changes on the same line. So that's why we kind of ran into that. So now let's do a little bit of a demonstration. So I'm going to basically show you the exact same repository. So here is the repository on remote, and I'm going to go to the Git lecture 2, and you'll see if I go into here, README, you'll see we have the same list, right? We have watermelon, onions, clipboard, and marker. So now looking at these two, here's what we're going to do. On the remote, what we're going to do is we're going to say, let's add, or we're going to change marker to pencil, okay? And we're going to commit with a terrible commit message just for the sake of proving a point. And you'll now see we have pencil there. But locally, what we're going to do is we're going to change marker to be pen, okay? And so now let's save that, and we're going to add the README, and then we are going to commit it. And finally, we are now going to run git pull. So now you'll see what happened here is it says it's pulling it, it unpacked it, and then it's going to try and auto merge, just like we talked about before. And then it says conflict, merge conflict in readme.md. So automatic merging failed, please fix the conflicts and then commit the result. So let's go back into readme and let's take a look at what happened. So just as we said in the lecture, you get this head, which is telling us what we did. You get the equals telling us what the end of what we did and what the start of what others did is. And then we have what everyone else did. And then we have the commit message or the commit hash. So in this case, it's super long, and that's just because Git has gotten more and more advanced over the years. It can really depend on the size. So what we're going to do is we're going to clean this up a little bit. So we're going to get rid of all of the placeholder stuff that we're looking at with the Git conflict, and so or the merge conflict. And now we're going to decide, Do we want to keep a pen and a pencil? Do we just want a pencil? Do we just want a pen? In this case, just to show you that you can actually keep both, I'm just going to save both. So now what I'm going to do is save that file. Then I'm going to add the README again. I'm going to commit it, and I'm going to say fixed merge conflict. And there you go. Now I can push it back up. And you'll see once we do that and I refresh the page on GitHub, we now have pen and pencil. And so this was pretty easy. This was a relatively easy case. But what if we were working in code and we had some crazy long thing that we just did not know, whether like we have for loops everywhere, we have a while loop, we have all kinds of different commands. When that happens, we're going to run into an issue where we don't know what we want to keep and what we want to move into other areas. And that becomes a much more complex problem. And that is where the next part comes in soon enough. So, that being said, we're going to start off with our first poll question. All right, so now is the time to go over to hashtag Pullbot and start voting with the reaction. And so I'll just read out the question as well. We want to pull from remote, but we've committed a change on the same line as the change made from the remote since we last pulled. What happens? Okay, it looks like bot's broken. I'm going to message the bot builder on that. Okay. So the correct answer in this case, although it randomly disappeared, is 2. And that's because the Git poll that we're going to run is going to merge. And as I said before, we're on the same line as before. So that's going to cause the issue that we were just looking at. Let me just fix the Pullbot real quick. Okay, great. So now I know, a little bit too easy. I forgot something to do beforehand. So the correct reason is because, as I said, it's on the same line as a change we made before. So let's ask a different question. I know it looks very similar. So I'm going to create a new question. And this time it should not break, hopefully. So yeah, this one is we want to pull from remote, but we've committed a change in a different file than the change we made to the remote since we last pulled. What happens? So I'll give everyone another 15 seconds or so. All right, I'm going to close the poll now. Okay, so first off, awesome for nobody choosing 4, just the shrug. And then among everyone who did choose an answer, about 50% said Git will reject the poll. So I'm going to ask, why would that happen? Remember, we committed a change in a different file than the change made to remote. So Git isn't going to reject it. It's actually going to automatically merge it for you, because remember, Git will only run into an issue and have a merge conflict when you have a change on the same line. So if we look at this example, right, Charger is on a line that didn't get changed on the local repository. So it didn't actually cause a merge conflict because there was no issue. So it's only when they're in the same area. In this case, it was a completely different file, so we didn't run into an issue. Tim, I think we're good on the bot this time around. Just in case you're not watching the stream, I'm going to message you as well. So Git will reject a commit, or Git will reject a merge, or a pull, when you have uncommitted changes to files. So a good example, if I go back to the terminal over here and I open up the README, right? And let's say I just make this a slightly smaller header, right? Now, if I try and do Git pull now, well, it's going to say I'm already up to date. Let me change the remote just to make the point. So, highlighter, sure. All right, so if I try and Git pull now, you'll see it's going to say error, your local changes would be overwritten by the merge. So please commit them or stash them before you merge. So this is the case where it's just going to outright reject it, and that's going to be only when you run into an issue or when you haven't committed a change. And that's just because obviously it doesn't have the snapshot. Someone asked, do we still get credit if it's wrong, if you answered wrong? Yes, you do. The questions when they're live are purely just based on participation. So that's the one case where you'd run into that. Ignore this command that I'm running right now. I think I messed that up. Yeah, I all caps it. Okay, so ignore that command that I just ran. And I'm going to pull down the new change because we now have highlighter. Okay, so let's go back to the slides. And let's talk about branching in Git. So as I said, when we were pulling and then dealing with these merge conflicts, it gets really messy really fast. It's really annoying, especially when you're dealing with real code where you have 20, 30 lines that are more complex. It becomes really difficult to figure out what you want to keep and what you don't. So I saw a new message. Okay. So branches, the whole point of them are to isolate work in progress from completed work. And so you'll see here that I mention the master or the main branch. And that's because we're in this weird transition period due to a lot of like issues with the word master and its connotations. The software engineering industry has started moving towards the use of the main branch instead of master branch. As of right now, it's still in that transition period. A lot of versions of Git still use master. In our case, the GitHub Enterprise for U of I still uses master as far as I'm aware, and it's something that apparently we can't change, so it's just kind of there. So you'll hear me refer to them as both. Point being is you'll usually hear me refer to it as master, but you'll see it as main in a couple of places. It just kind of depends on which version of Git you're using and where. So yeah, the idea is that you want to isolate the progress that you're still working on that still might be buggy and still hasn't been fully tested to your complete work that you would actually give to a user. So let's talk about branching. So if we look at this, right, we made our first commit and we pushed it up, no problem. Then we're going to make some more changes, and this is great, okay? But this is getting kind of messy, and instead of just continuously committing along a straight line, what we're going to do is we're going to say, okay, this is our favorite page so far. It works. We can release it to our friends. We don't want to mess it up anymore. So I want to keep working on it, though. So what I'm going to do is I'm going to branch. And so I'm creating a new branch that's separate from the main branch. And I'm saying, okay, we're going to add a settings page. Okay, so now I can keep working on the new feature. Let's say I fix some more stuff, I get it almost done. But then while I'm working on this, someone mentions that there's a bug with this page and it needs to be fixed. In that case, I'm going to go back onto the master branch or the main branch, and I'm going to change it depending based on what I need to fix. And then now we have these two separate branches, but just like we did Git Pull, we can Git merge these branches back together, and now we have all the changes all in one place without having risked this page due to anything done on this branch. We could have easily just said, that branch didn't work, we're not going to work on it anymore. So the point here is to have a feature branch which is basically a new feature that isn't fully tested and isn't ready for use yet. And then we have a master branch. And the whole point of the master branch is basically that is the version that we are willing to release to people and we think is good and doesn't have any issues with it. So that is branching in a nutshell. Let's talk about heads. So you may have seen the very violent phrase, you are in a detached head state. And what that means is that the head is no longer connected to where you're looking on Git. So the head is basically this idea of a pointer that points to the latest commit on a branch. So in this case, on the master branch, that's the head, whereas on the feature branch, that is the head. So in this case, we have two heads depending on which branch we're looking at. So if I checked out the feature branch, my head would be over here, whereas it would be over here if I were on the master branch. If I went back and said, I went to this commit and I looked at this commit specifically, that's when you get a message that says you're in a detached head state because you're no longer looking at the head of a branch, you're looking further back. And that's important because if we make a new commit from that commit, it's not going to be on this sort of tree that we're looking at here. And so that's why that's important. So here's a frequent question that a lot of people ask when they first learn about branching in Git, and that is, will you get a conflict when you're merging into like master? And the answer is yes. Just like with a pull, which is a git fetch and a git merge, if you have a conflicting change in a similar area of code, it's going to cause a conflict. However, any other time, it's not going to be an issue at all, and it is just going to work fine. So this idea of merge conflicts can happen anywhere, but it usually only happens when you change the same thing in two different branches or two different locations. So that is the basics of branching. Let's have another poll question. Let me launch the poll. So yeah, this question is, before you make a major change to your team's project that will impact everyone on the team, what should you do first? You can email them, let them know that they shouldn't commit until you're done, so that way you don't have to deal with the merge conflict. You can create a new repository, make the changes there, copy paste a project folder somewhere else, create a new branch, or let them just deal with merge conflicts. All right, I'm going to give everyone about another 30 seconds here. Okay, I'm going to close the poll. All right, it looks like 90% of you said create a new branch, and then about 10% of you said copy paste the project folder somewhere else. So copy pasting the project folder kind of circumvents the whole point of Git. And fun side story, I actually know someone who was so afraid of using Git that he basically did Git just by copy pasting files and zipped them up and just kept them in different places on his directory. However, that's defeating the purpose of Git, and instead what you want to do is create a new branch. So that way you can always reverse away from you can always reverse your changes and not have to affect your main branch. So the answer is 4, but I can see where 3 is, but it defeats the purpose of Git, right? In an ideal world, everything that has to do with redundancy is done via Git. Okay, so let's talk about best practices. So the first one is keeping your master branch clean. This is the version of code that, as I said before, passes tests, builds, compiles, and can be deployed to users. This is pretty simple. The idea is that whatever your main or master branch is should be what you are proud to show someone else, right? You should have the ability to show that off at any point in time, and it will look good, and you will be proud of what it looks like, unless you're like in a very early state and you're still setting it up. Next one is name your branch as well. branch 1, branch 2, branch 29 isn't going to work. You're going to forget what the branch names are. It's just not a good practice. So instead what you should do is name them something useful. Think how we talked about conventional commits, right? It's the same idea. Instead, what we're going to do is we're going to say feature, and then the name of the feature, or fix. Here's what the bug was. And the idea is that we name these branches so we know what each branch is doing and why that branch is open right now. So the final thing is something that we'll come back to on Thursday, and that is reviewing the code before you merge it into master. This is basically keeping the first point in mind. The whole point is you want to keep that master branch clean, and the easiest way to do that is to make sure that someone else looks at what you've done before you merge it back in. So we'll talk more about that on Thursday, but until now, we're just going to pretend you're doing that in another way. So let's review commands for branching now. Let's talk about how you branch in the command line. So the first thing is you run git branch and then put a name, and that will create a new branch for you. So then you're going to git checkout that branch. So I can say git branch feature build website, then git checkout build website, and then I will move to the next branch, and it moves the head pointer and updates all the files as we talked about before. If you want to create a new branch in the same line that you're checking out a branch, you can use this -b flag to just create it and switch to it all in one. Then git merge is going to merge those branches back together and put them back into one branch. So let's demo that, okay? So what we're going to do here is, if I can find my mouse, there we go. We're going to check the status of Git. All right, so we are on master right now. And what we're going to do is we're going to git branch, let's say we want strawberries. Right, that's our new food for the list. So now, if we check git branch, you'll see there's a second branch called strawberries. So if we do git checkout strawberries, autocomplete does not work. There we go. So it'll say switch to branch strawberries. So now we can go into our README and add strawberries to the list. There we go, and strawberries. And we'll save that and quit. We will add the file, and we're going to say add strawberries. Okay, and then we can push, but you'll see it's going to say fatal. The current branch has no upstream branch. So once again, Git being unnecessarily violent, it's telling us that we've done something wrong. So it actually gives us exactly the command we want, and that is to say git push, set the upstream for the branch we're currently on, or actually set the upstream for origin on branch strawberries. So we're going to run that. And now it's basically saying, okay, GitHub, here's a new branch, here's all the changes to it. And now if we reload here, you'll see there's the strawberries branch, and we can check there's the strawberries. And so a good way to visualize this is this network tab over here. You can now see here's from when we were doing that poll earlier, and here's how we branched off onto the strawberries branch. So that is the idea of branching and then pushing that to remote. So now let's talk about merging. So the way we merge is basically by using git merge, and then remember git fetch. If we wanted to, we could git fetch somewhere on the origin and then merge it in ourselves manually instead of running git pull. The reason we do git pull is just because it's a little bit easier and a little bit faster. So that's kind of why git pull exists. It's easier. So let's go back to our demo, and we're going to switch back to master and show how to merge a commit back in, or a branch back in. So we are going to git checkout master, and now we're going to look at the status. So you'll see we're on master, and then if we look at git branch, strawberry still exists. So how are we going to fix that? We're going to do git merge, and then we are going to do master, and then we're going to type strawberries. And so what this is going to do is it's going to try and merge them together. And there you go. So now if we look at the README, we have strawberries. And if we go back out, I have done something, there we go. If we go back out and then we run git status, you see we are now ahead of origin master by 1 commit. And if we look at git branch, the strawberry branch still exists. So if we do git push, now that's going to get pushed back up to git. And now if we go over here, you'll see strawberries got merged back into the master branch, and you'll see here that both of them are now on the same point. And so the reason there's a strawberries tag here is because the head still exists for this branch. And so if you want to get rid of them, I'm actually not too familiar with the command for it. Let's find out. So yeah, you can do git branch -d. So let's try that. Git branch -d strawberries. There we go. And now if we look at the branches, you'll see we're just back to master. And so the reason I wasn't too familiar with that is what we'll get into in the next lecture. But the point is you shouldn't really need to do much merging as long as you're doing pull requests, which once again, we're talking about next lecture. So let's go back to the slides and let's kind of talk about what this workflow is. So the whole point of this workflow is to branch off for a new feature, bug fix, whatever, and then to make changes as you please, to basically do workflow one in succession. So going back to the branches, here we go. So as we said, right, you branch off and then you can start making new changes as you want to go, just like you would in the workflow that we learned last time. And then when you're done, you merge it back in to the master branch. So let's go there. So yeah, you can merge it back in, and there you go. We'll cover our third and final workflow in Git Lecture 3, and that's going to be the one that we talk about how CS196 does it, specifically with our projects, and what a general kind of workflow that you would see in industry will look like. So now let's talk about a couple more useful commands. Somebody asked, is it common to want to delete a branch? It depends. So the answer can depend. The usual answer is yes. After you're done with a feature, you want to delete it. So like, for example, if I have a branch called login page, once I'm done with the login page, I probably want to delete it. And so what GitHub will do when we do the steps that I'm going to talk about on Thursday, it will actually give you an option to automatically delete a branch. And so that's why I wasn't too familiar with the command. It just kind of depends on your use case. You can also have a branch like a work in progress branch. So the master branch can be your perfect branch, whereas the work in progress is a bit more of a beta type of branch. And so you'll see bigger companies, especially with larger products, sometimes do that. So let me just check. Okay. So these are some random commands that are just kind of useful. You saw me use them a little bit. It just kind of depends. So the first one is git status. And so what git status will do is it'll tell you exactly what's going on. I'm going to clear this so it is a little bit easier to see. It'll tell you where you're at on like git. So we're on branch master, and it says we're up to date. If we add any files that we could add or commit, it'll tell us right there. But there's nothing to commit, and our working tree is clean. This is a pretty great message to see. It means you're all up to date. Then the next command is git stash. So a really good example of this is if you tried something, it didn't really work, but you want to come back to it in case like you think it'll work later on, but you're not sure. And so like, let's go to our README again. And let's say I wanted to change this to a singular strawberry, but I wasn't really sure whether I wanted 2 or more. What I could do is git stash. And so now it tells us that we have we've stashed them. So now if we look at git status and we go into README, you'll see it's back to strawberries, but we've saved that stash. And what we can do is we can always apply it later. So we can go git stash apply. And now what you'll see is if we go back into the README, we have that singular strawberry. So if we decide, oh, hey, I now want to use that, I can go do that pretty easily. Then we have git log, which is going to show us our like history. So if I do git log, you'll see, here we go. So it says the author name, which is me, gives you my email, and then it will say, here's when that commit was made, and then the time zone is over here, so you can tell I'm in Champaign, and then it will give you the message. It'll also tell you the branches and all of that kind of stuff, and you can kind of scroll up and down. It acts like Vim, and then when you're done, you can just hit Q, and it'll bring you back out. You can also do, I think, one line, like this, and it'll give it in a much more readable format. So this is if you're just trying to kind of find a specific commit, and then you can copy this, and let's talk about that. So we're going to take a look at updating. Well, we'll take a look at this one. So now what you can do is revert, reset, or reset hard. This was the command I mentioned you shouldn't be looking at when I typed it in. So you'll notice that these all have a shorthand for it. So I can copy that and I can say git revert and then there. And oh, right. So first off, I'm going to reset back to the head. And now if I do that revert, you'll see, let's see. Okay. So now if I do git revert, that should have worked. Oh, this does the merge conflict. So if I clear git reset dash hard, this is what I use when I just make a mistake with Git and I just want to get back to the last commit I made. So if we go back to the log, let's go to this one where we added strawberries, right? So if we copy that commit, and then we do git revert, now you'll see it will show us reverting, and it actually allows us to keep them safe while also reverting. And we can basically say, this is the one that we want to go back to without having any, like we can keep git commits 2 and 3 here, but go back to 1. And that's what you see here, right? So you see this linear line that says we made commit 1, 2, and 3, and then we reapplied 1 because this is the one that we think was better. So that's basically a little bit of a different way to do git stash, just depending on what you think is better. This is if you made a mistake, you see it down the line and you want to go back, but you want to keep those changes just in case. Git reset will reset it to the previous state, wiping out these previous commits. And then finally, git reset and then the old commit dash hard is going to do the same thing, but it's going to stage all of your changes. So it's going to basically delete any changes that you've made. And so both git resets are going to be much more dangerous because you're obviously going to lose this history, but it can be sometimes nice when you just kind of want to reset the slate and just get back to a working point. The most I use is git reset dash hard. If you don't put an old commit, it will automatically reset to the head, which is very useful when you want to do something like revert back to the last state that you had before you change any files for your last commit. So if I made a couple changes, but it turns out that it completely breaks anything, I can just go back to my last good commit by doing git reset dash hard. So that isn't everything about Git, but this is quite a lot. This is handling branching, merging, all of the big important things that we talk about, and then there's still more. You can talk about handling Git errors, learning some more commands, getting comfortable with a bunch of different like little useful commands. There's all kinds of different ways to use Git. You can do all kinds of crazy things from using local servers. You can set Git up as a remote on your own computer. There are plenty of different ways to use Git. The point being, this isn't everything. Git lectures 1 and 2 are basically teaching you about Git. In Git lecture 3, we're going to talk a lot more about how a real user would use Git in an everyday world. And so this is basically the end for learning about Git commands and anything crazy about Git like that. But this is going to, these two lectures have told you basically everything that you should need to know on a day-to-day basis. So let's talk about something else that's really cool. So we're going to go back out and we're going to reset this. And let's take a look at something which is how we check Git. So if we do that, so you'll see there's this .git folder. And some of you asked this somewhere in office hours or something like that, either what the .git folder was or how Git keeps track of everything. And this is how. It has the .git folder. So if we go into there, it's a hidden directory, but we can open it up. And you'll see there's all kinds of different things in here. There's commit messages, there's the config, there's a description, here's the head, the fetch, all the different types of heads, and a bunch of just different stuff in here. And this is how Git keeps track of everything in this .git folder. So interestingly, if you want to just pretend a Git repository was never a Git repository, all you have to do is remove that folder, and it's as if you never did Git with that folder. So the idea there is this is how all of this mechanism gets kind of kept track of. So that is pretty much everything that I had for today. Let me go to the next slide. Oh, this is the last slide. Okay. So yeah, that's everything that I had for today. I'm going to stick around for questions. But yeah, that was pretty much everything about Git itself. Thursday, we're going to talk about the usage of GitHub and how to work in a team collaboratively. And then Tuesday next week, we're going to do project kickoffs. It's going to be a really fun time. You're going to get to meet your PM and everything else like that. In terms of your PMs on the homework, right? It says assign your PM. That isn't the same this semester. And instead, you're going to wait until a little bit later on. And then the only other announcement that I have is that the social hour is starting in about 15 minutes. So if you want, come to that. I'll be there. I think maybe Eustace will be there. And a bunch of other people are going to be there. It's going to be a lot of fun. Once again, somebody asked a question. Yeah, so this is a good question. So let's go back to the slide. So this is what you're going to want to do. Yeah, no problem. I just had to take a minute to read that. So this is what you're going to want to basically look at. So in this case, what you're trying to do, I'll repeat the question for people who can't see it. So I have an issue where I made new code on two computers, C1 and C2. So those are two different commits. And I already pushed on computer one. Now I want to delete any changes that are on computer two, but I already made the changes, committed them, and it says I need to push before I can pull again. But I don't want to push the stuff on computer two because I already made the changes that I want on computer one. How do I solve this? And just pull my changes from computer one onto computer two. So the way that you do this is by using the git reset command. So in this case, right, there were changes that I'm going to present this again. So in this case, there were changes that you wanted to make or that you made that you now want to get rid of. So in this case, you're going to want to use git reset and then basically say whichever commit that the last commit that computer one and computer two both had. And that's basically because you're saying, okay, I don't like any of the changes I made. I don't want to keep them. I made the changes on a different computer. So I'm going to git reset and then I can then git pull from remote and I'll get all of the changes I made on the first computer. So that's going to be the command you want to use. Does that make sense? Yeah, no problem. So yeah, I'll stick around for another few minutes on questions. I'm also going to catch up on Twitch chat. So yeah, somebody asked, is there social hour today? Yes, there is. It's going to be exciting. I'm not sure what game we're playing, but I know there is going to be a game option. Um, okay. All right, so does anyone else have any other questions? This is going to be the sort of last call for the night. All right, awesome. Well, thank you so much for coming back to lecture. Git 2 done. You've learned pretty much all of the Git commands you're ever going to need. And next time we're going to talk about using Git collaboratively. It's going to be a lot more fun. There's a lot more GUI based elements for those of you who don't like using the command line. It's a little bit more friendly. So can't wait to do that lecture on Thursday. Otherwise, have a good Wednesday and rest of tonight.